Good afternoon, everyone. Our next speaker is Kyle Jackson, who is very graciously agreed to give a talk this afternoon after there was a cancellation. And unfortunately, the talk's going to, well, not unfortunately. Fortunately, the talk's going to go for 8 hours because it's actually a whole day's worth of work in 40 minutes. But please welcome Kyle.
All right, is that working? Can you all hear me back there? Is that, yeah, excellent, brilliant. So like Dave said, this was actually an 8-hour tutorial on Tuesday. It's not 8 hours long. I tried to cut it down as best I could. I do have a demo at the end. I don't know if we'll get to it, but we'll see how we go. But crux of this whole talk, or the whole tutorial was on Tuesday, was essentially APIs and all the terrible ways you can essentially do them. There was a discussion, I think, about calling it how to not get optist, but that was not a great idea. So we'll digress. So who am I? I'm Kyle. I'm an InfoSec manager by day, and then by night I like to write a lot of software. It's probably not great, but I do it anyway, so it's all good fun. So why do we care about API securities? Buzz Lightyear is the developer. They love APIs, love building things like, let's give data away, more data for everyone. We are Woody going, that is a terrible idea, let's not do that. They will do it anyway. So, you know, with the Optus thing aside and everyone else aside, it's still a key thing. We have to understand it. They're not going away, they support everything, so let's just talk about it, understand what the security issues are and what they can really do. Security incidents involving APIs, they are many. These are a couple. So obviously Optus. Now I will say allegedly, because I don't think it's been completely confirmed, but allegedly it was an unauthenticated API existing for 5 years, give or take a bit. Twitter was a good one. It was just like you could scrape the API and take as much as you want, and that's totally fine. AT&T 3 weeks ago was a good one. That was like, let's go and breach their backend systems, create some mail tokens, and then hit their API and scrape as much as we can. That has apparently led someone to losing $20 million in Bitcoin, so that's probably not super great for them. You know, so we go to APIs and we think, all right, we've got an API, it does a thing. But really the first question is like, where are they? How do you enumerate them? How do you know what's actually there? What's the surface area of an API? And more often than not, you don't know what's actually there. So documentation is key. Devs don't do it though, not very well. A lot of the time you'll see public APIs, they are fairly well documented using something called an open API or Swagger file. Vendor neutral. So it's really good. JSON or YAML, I would recommend YAML. JSON's really hard when you're building these things, especially when they're 10,000 lines long, and JSON adds another 10,000 to that. Generally used for public APIs, but there's nothing stopping a developer from actually creating it for a private/internal API. And I'll get to internal and privates in a minute because I think that's also a big misnomer and a little bit of a scary topic. But you can also document it. You can be like, hey, I wrote some cool code, does some cool stuff. I'll put it in Confluence in about 3 months' time, and it'll be partially correct, and then you'll come back later and it's actually missing things. But it does work. It can be done. GitHub READMEs. It's just not as nice, and it's not as easy to work with, especially if you're doing a public API, and you're a client developer. On a client side, you're trying to develop, you're like, well, how does this thing even work? Like, how do I test it? What's the models? What's it look like? So it's not super easy to use, but you know, it's viable. More often than not, you've got to read the code. I can tell you the story of where I worked at a company, and I won't say which companies I work for, but I'll tell you a story. I wanted to integrate with a management platform, management plane for a particular service, and I was like, hey, how do I get access to it? They're like, well, there's not an API, but there's an endpoint. It's not documented, and I'll create a token for you, and I'll put it into an environment variable, and that should just work fine. So that was an API technically, but just not documented. How it worked, I had to read the code. There was a lot of C#, and it wasn't very fun. So more often than not, you sit there having to read code and understand how it actually works. Harsh reality more than anything. So we kind of, get a documentation. We've got it documented. We don't have it documented. And then we're talking about authentication. So how do we authenticate things? And it's a bit of a tricky subject because the default answer is, and I heard this on Tuesday before my talk, I was walking through the lobby and someone goes, API security is easy. You just authenticate it. Okay, that's easy. We'll talk over. Let's go home. Let's authenticate it. But that didn't happen with a certain company, apparently. So authentication is hard because in some cases, you actually don't. So I guess I'll go back a little bit here for a second. So why do we want to add authentication? For obvious reasons. Let's protect our data at some level. That's the obvious reason. Let's do it. On the private and internal API, that's a bit of a mess. So people will say, I have a private or internal API, and then you'll say, how private and internal is it really? And they go, well, it supports the web page. You're like, okay, well, that's not private or internal. It's private because it's not documented, but you can just get to it anyway by just doing the direct API call and just skip the whole web page thing. So, F12, developer tools, find API call, take token, make things happen. That's a valid API. That is not private, that is not internal, that is a public API that is accessible. If your API is on a network in general, I would still deem it publicly available at some level. Your laptop's connected to a network, you can access it at some level. And so it goes into the point of saying devs will go, but dev and staging and testing, why do I have to add authentication there? Because it's, dev, what could go wrong? More often than not, I have seen many companies, and one in particular, where a data breach was caused because a particular person in the company got some data off a staging environment, and it was supposed to be scrubbed of PII, and it was. But what they didn't do is they didn't scrub the comments section where the account managers could go and put arbitrary data in. Now, ironically, that data also contained the same PII that the other fields contained, because they were like, hey, such and such customer at email address at company has this thing in their system. You go and leak that publicly, you've just leaked the same thing. So do they need authentication? Yes, they do. Do you need to scrub data properly? That's also, yes, you do. But in some cases, no authentication is also a valid method. You sometimes don't need to have authentication. Maybe your system needs to show things publicly. Maybe, I don't know, taking a guess, your Woolworths. Maybe you list everything publicly because you don't care if people see that you have beans in stock. Okay, I guess that's probably an issue, probably fine. But if you're hosting credit cards, that sort of stuff, maybe you shouldn't go and, not authenticate it. Authentication is many and vary. Basic authentication is very, very common. As a gentleman on Tuesday mentioned to me that the federal government has released a beta article on API security. And it says in there, do not use basic authentication, it is bad, but everyone uses it. So it's not sure on that one yet. But effectively, it's any arbitrary string. The RFC will say it's a username and password with a colon in the center, base64 hash it, and you encode it, and you're good to go. But you can make any string you want. It can be Kyle is awesome or Kyle is terrible. Doesn't really matter. And you can put it wherever you want. You can, authorization basic key, that is the valid approach for doing it. You can do authorization key, that's fine. The bottom one there is I've done a lot of work on MITRE's CVE services. That is the essential API that drives the entire CVE ID system, how you reserve them, how you submit them, et cetera, et cetera. That is how you authenticate to the API. Talk to me later whether I like that or not. I won't say it publicly when it's recorded. Query strings also work too. You can go put a key in a query string. Obvious reason is you do that and you log that, you've logged everyone's keys in your logging system. It's not really great. Obviously, these are all inferring that you have TLS on your transit layer, so no one can see them just by looking at traffic. HMAC's a funny one. Hash-based message authentication code. Slack uses lots of it. Essentially, you can be used to authenticate someone and also verify the message hasn't been manipulated in transit. Uses essentially public keys, private keys, uses a hashing algorithm of some description. It should use timestamps to prevent relays. Really great. There is an overhead and it's a little bit harder to work with, but it can be done, it can be used. But more often than not, you'll see OpenID Connect. It is an extension of OAuth2. OAuth2 is not authentication, it's authorization. OpenID Connect is the extension of that. I'm pretty sure Okta wrote the extension. I could be wrong, so if I am, please let me know, but I'm pretty sure it's Okta. It is used primarily because it is the safest way for front ends to authenticate. So if you have a front end web application, you've got 10,000 users using it, you don't want to hard code an API key for every user and say, hey, that's how it is. So we use OpenID Connect. Really nice to use, but it still has the same security issue of basic auth in that you can steal the token. It happens all the time. Great way to bypass MFA. Steal the token, replay it. But there's a way to get around it. Let's refresh the token, shorten the lifetime. But if you're like people, we don't like that stuff. We want a 90-day session lifetime because we don't like logging into things. So it negates every benefit of that effectively. So it's important when we're looking at OIDC is to make sure our session lifetimes are appropriate for our business risk. Building your own authentication and authorization provider. This is a terrible idea through and through 1,000 ways. Unless you're Atlassian or Microsoft or any of those big companies who have thousands of people with lots of security and lots of money, do not do this. It will end you in really, really bad times, either now or in the future. So a couple of vendors there, Auth0, Cognito, Azure, yada, they all do it. They make it easy for you. Just go use them. Some are free, some aren't, but it will save you a lot of pain, a lot of heartache in the future. So authorization, the second component of authentication. And I apologize I'm going quick because there's a lot of content I sort of want to get through, hopefully get to a demo which will show some cool things. So we've proven who we are, but what can we access? So a lot of the times you'll have an application which is you've authenticated and congratulations, you are God mode. Everyone is God mode. All right, then fair enough. Maybe that's the business requirement. Most often not, it's not the case. It's just developers did a developer thing, didn't add authorization, and happy days. So essentially, and this comes down to how, if the account's compromised, well, how do you essentially validate that they should have access to that? If everyone's God mode and everyone gets compromised, well, it's a bad time. If you have readers, obviously, those levels, that really adds a lot of extra security to your application or to your API in general. In the tutorial on Tuesday, we showed that where essentially some endpoints could be accessed because it had no authorization at all. Others couldn't be because we had authorization on it. So you had valid credentials, but no authorization. And where you sort of end up in this whole authorization mess is this whole insecure direct object reference issue. And it's in OWASP API top 10, I'm pretty sure. And it's all about saying you access an object directly without authorization to access it. It's fundamentally a broken authorization issue, not a vulnerability in and of itself. An application will always expose what IDs it uses, but you shouldn't be able to just go and say, hey, I'm Kyle in Azure AD. I'm going to go and talk to Microsoft's Azure AD because why not? It shouldn't work that way. How do we prevent it? We do proper authorization. We do data segregation as well. And how we identify data is super important. We don't want to be doing this. Developers will love to do sequential numbering because it's easy. It's, I go 1 to 1,000,000 or, cool up 1+. But it's very easy to go, burp suite, please, I know that you've got 1,000,000 number here, you've probably got 1,000,000 customers behind that, let's just iterate each and every single one. So, never a fun time. GUIDs are the way to go, they are awesome. By the way, there are so many versions of GUIDs, it's ridiculous. Version 8 is like, do what you will, but just call it a GUID. So really weird, but v4 is what's mostly used, it's cryptographically random, and it should be random. If you want to read up about it, the RFC's there. It's terribly boring. You will definitely fall asleep. It's like tennis at midnight, so, but it's there. And so back to data segregation. We're saying, it depends on what your app does. Maybe you don't need to segregate data in this sense. So what we're saying is like, if you take like a multi-tenant SaaS app, let's take Confluence, right? Their data has to be segregated. You can't say, well, every customer gets the same database or the same set of data. What could go wrong there? And so that data segregation strategy is really important, and that will actually protect you from bad outcomes. How do we implement it? We create some sort of tenant value, and we use that value in every single database query to prevent someone from accessing some nasty things. And I will also add there that we need a way to add it to every request that cannot be modified by the end user. So it's not great if you can let the user modify what tenant they're in. They'll just change it to the other tenant, and then it's all broken anyway. And these all seem very logical, but these sometimes don't happen and lead to bad outcomes. Data security. I cut out a whole section here on TLS and encryption at rest because I think everyone should know that. We encrypt at transit, makes sense. We encrypt at rest to prevent the AWS engineer from rocking up and pulling a hard drive out and taking all your cool secrets. But what's not really spoken about is, what about your sysadmin or your DevOps engineer who can read the database and look at every single line and go, well, I can read that data about that person because I have access to see it. That's when we talk about encrypting data, hashing data, and tokenizing. I will preface, I am not a tokenizing person. I haven't really done it, so I'll mention it, but I haven't done it. Encrypting data, PII, medical, financial, that sort of stuff. We need to encrypt it. It is better to be encrypted than not. If your database is leaked, hopefully your encryption keys aren't with it. And if they are, then that's a really bad time, and that's unfortunate. If you're LastPass and you've had some crazy APT who's gone and stole your database and gone, hey, your encryption keys aren't there, let me go and hack a Plesk server, hack an engineer, steal an encryption key, well, then I'm in at that point. More power to them. They've tried a lot to really get it. But you need to encrypt it. Many of these applications, MongoDB, SQL, they have abilities internally that lets you do this. It's very important. Symmetric encryption is usually used for encrypting this sort of data. use a provider's encryption method. Go use AWS KMS, go use Azure Key Vault, go use GCP KMS. I think even HashiCorp's got one. Do not go and put an encryption key in like an environment variable or hard code it in the application. That's not going to end well for anyone. Also, the whole rotation problem there is really bad. I spoke to someone just recently here at the conference. He's like, we've got a similar issue. We have to kind of somehow get onto a better encryption standard. Encryption process is very straightforward. We're going to power through that pretty easy for symmetric encryption. Same key to encrypt, same key to decrypt. Asymmetric, again, we all use it every day. Websites, they use it all the time. It's a little bit slower than symmetric encryption, probably on milliseconds, I'm guessing, but it's a bit slower. That's the general process there. You encrypt it with one key, decrypt with the other key. Happy days. And then where do we store our keys? As we said, storing is important. We can't just store them anywhere. We can't put them in environment variables. We can't go and just drop them into anywhere. We've got to be very, very careful about how we store them, what we use them for. Obviously, rotation is key as well. A lot of providers allow you to import your own, if you will. Rotating is important as well. If we can't rotate easily, if we have the same key for the next 20 years, how do we know that that data is still secure in 20 years' time? It may not be. It may have got out at some point. What if you do have a data breach and the encrypted material is leaked, but you still want to maintain business and that sort of stuff? You've got to rotate it. Well, you don't want to lose access to the old data, so you've got to rotate it somehow. So how does that work? Best case, go to a cloud provider. They do it all for you. It's nice and easy. And then we sort of get into the hashing discussion. Hashing's a fun one. It's a bit of my passion, hashing. I think it's interesting. It's done terrible most of the time, I've found. I just recently saw something where someone's still using MD5 to hash passwords. I don't know why they're doing that. It's a bad idea. It depends on the type of password, the type of data you're using to hash. Entropy is important. So obviously we're sort of more on data hashing here, but password hashing, sorry, but it's important to discuss it. And this talk in general, this tutorial I did on Tuesday, sort of covered a bit of web security as well, and that's why I bring this up. When we're looking at hashing algorithms, we've got general use algorithms, MD5, SHA-1, 256, 512, file-based type hashing. And then password hashing, like Argon2, bcrypt, etc. Password hashing is orders of magnitude slower than general algorithms, as seen here. So top one is a 32-character password or a value. SHA-256 is 600 nanoseconds, and bcrypt is 80 milliseconds. Second password, hopefully I have never used that since I was 8, but that was my password when I was 8 years old. Not great. But still, bcrypt is 81 milliseconds. So if you were to leak that database and try to crack every single one of them, well, you've got a delay of 81 milliseconds for every single computational try. It takes a long time, especially if you've got a really high entropy. But it's good for those passwords where you have low entropy, like my 8-year-old password, which I don't know why I did that, but I did. It could take a while to get that. The difference with the top one is it's got a very high entropy. It'd be very hard to guess that, so SHA is probably fine. It's going to take a very long time to try and crack that by brute force. As long as the time we got. All right, cool. Logging. So devs love to log all things, just like security people. It's awesome. Recording authentication events, recording network level events, so ingress requests usually, logging application errors, including stack traces are super cool. Sometimes like how many requests per endpoint, just so they get some like metrics on how much usage they're getting out of it. It's kind of cool. But sometimes it can go terribly wrong when you start logging stack traces to your clients or in like a web portal or your API endpoint, you're hitting it and it's just like, I get a 500, and you're like, that's cool, I broke something. But you get this massive stack trace of how the application functions. Not really good. Now, some people will argue black and blue that it's fine, it's good for end users to use that to effectively debug and help you debug your application. You can use that stack trace to, from a developer point of view, you can still log that, just don't log it to the client. Don't tell them how it functions. An example of that was a while back, there was a vulnerability that was patched in a product that I was working on, and that was cool, they fixed it. But then in fixing it, they actually leaked a stack trace which showed the entire internal networking of an AKS cluster and showed all the endpoints it was hitting. Probably not the end of the world, but probably not great either if you're an attacker going, what are you running on? You go, that's definitely AKS, looking at the network connections. You can also log too much data on the server side. I had a person I knew a little while ago, they said that they worked in a financial environment where they accidentally logged credit cards to an aggregator. That was apparently not fun. So can be a massive issue in those PCI DSS environments. Also working on the CVE services one, they had a little bug in there at the very beginning where if you created a user in the API for that service, it would actually log the user's secret to their storage. It was like a one-liner piece of code, change it by 5 lines, vulnerability was gone. But it was there. It was easy to make that mistake. It wasn't hard. Injections, and these are the fun ones. These were the ones that get you on the front page of the news. Injection attacks are easy. We provide a malicious data to application processes it, and it doesn't sanitize it, and it just goes, executes data, and we profit from the outcome. They're awesome. SQL injection, NoSQL injection, it's great for exfiltrating data. They happen all the time. They're in a lot of applications, usually driven from using poor queries, like building poor queries allow you to inject into them. Command injection as well, so allowing you to execute commands on a local host. I've got a demo that shows that off, and we can actually use that to go and exfiltrate some instance metadata as well, just for a bit of fun, for some lateral movement. So that's also good. There's also code injection, where you can inject code into the application and executes it as itself. So they are nasty. Most of the time, command and code will lead to some sort of persistence, and then onward to victory. We have also general security misconfigurations. So, like we've got APIs, we built some bad code, maybe we've done some good things. So we've maybe written some bad code, but we've got authentication, got some good things in there, but we've gone and leaked our secrets in source. Not great for a public API. If we've gone and put encryption keys in source, or we've got, again, key material in there, all sorts of weird things. Commonly, you'll find an AWS key, although AWS now will revoke them just about immediately if they find them in a public repo, so that's really cool. But any other service, you can put tokens in there, private keys, etc. A data breach that I worked on was actually because someone used a GitHub repo to store customer data publicly. I'm not really sure why you do that, but they did it, and it happened. So, I'm not saying don't use GitHub, but I'm just saying it can bite you sometimes. Cloud misconfigurations, I think the gentleman speaking before me was key on that was Capital One was they're using instance metadata service v1. That is not great. We should have enough time to show that off real quickly, what that means, what that looks like. But that can cause issues. Public S3 buckets or Azure containers, the same problem. So all these, everything's moving cloud, everyone wants to be in the cloud, it's all fun and it's all exciting, and that's great, but there are a lot of ways to make it break, and that can really cause you some serious problems. Instance metadata, as I explained, this is in every single cloud provider out there. It should be known, but I know of some people who are surprised that you could do it. And it is there. It's a great way to get lateral movement. It's a great way to break other things. And we should have plenty of time now to have a look at that, which would be good. So what can we do to reduce potentially security issues occurring? I mean, the previous talk was a great example. Everything in the previous talk was the best way to do it, was shift your security left, get some scanning in place. We want to get some configuration as code in. So testing, I'll start with our testing. Unit testing is from a development point of view. I'm not sure if it's the most appropriate for this whole security thing, but it's a point to make. It's testing the smallest functional bit of code, right? It may not show security issues, but it's good to have. The end-to-end testing is important. It's going to be able to mock the entire process end-to-end. That's where you can test your authentication, your authentication, and your authorization to make sure they're actually functional. Best place to test is when you're actually testing. When you're developing, right? You don't want them in production and going, oops, we missed to authorization on the admin endpoint. That's a problem. Penetration testing as well, same thing. It can be used. Like if you're ISO compliant SOC 2, it still says you must do a penetration test every year. So it does work, and they usually find things that you haven't found. Codifying infrastructure is very important. Makes life a lot easier. Allows you to audit it properly. You can set configurations properly. All those good things. And as I said, the previous talk was great because it's like you can use those tools to help you essentially go and audit those configurations. API gateways, they are, I don't think they're great. I think they're okay, but they're not a silver bullet, and they're not going to solve everyone's woes. The reality is that if you build an API, like right now with an API gateway, maybe you've got 10 of them, you have to implement everything 10 times, and that's fine. And you might get it wrong once, or 10 times, it depends how you go. API gateway, you've got to get it right once and once only. So if your authentication is broken on an API gateway, then it's broken for every single API exposed behind that. So you expose 100 APIs, you break one authentication, you've just exposed everything. And so that's a really bad time. So not saying they're bad, but I think it's just, again, we need to be mindful how we're doing these things, building properly. I know of a little while back, there was a particular API gateway that you could just register a service against, and it would just be like, yeah, cool, let's go. So if you wrote some malicious code and just said register please, it'd say, yep, I'll expose it, no problems at all. So let's pray this works. I had just, how it all kind of went down, I finished the tutorial on Tuesday, went down to the, up to the room, came back down for dinner, walk out the elevator, Beck and Colby are standing there, Beck's like, we need you to talk on Thursday, and I had just deleted everything 5 minutes before the fact. So if I was told 5 minutes before, it would have been fine. But we're going demo, and we're going to hope this works. It may not, but let's see how we go. All right. So what I'll preface is we have an API hosted in Azure and AWS. I'll work on the zooming. That was a thing on Tuesday. Zooming was terrible, so we'll zoom in to make things happen. We do Command plus. And my point on Tuesday was the same, is that someone should write an RFC on how to zoom applications, because it's different every application. So we've got an API hosted in, can you see that at the back? Is that legible or is that terrible? Good? Excellent. So we've got an API hosted in Azure and AWS. This one's Azure. I think we've all seen AWS instance metadata abused to the nth degree this week. So let's give Azure some love today, because they have the same problem. It's just a little bit more difficult. So this API implements a health check with a host name. So I don't know, this developer had a really, really great idea of saying, let's check what host my app's running on, because I run in containers and I have 10,000 of them, and I have some cool automation, and apparently this is the only way I can do it. So what it should be saying is, in here we should be saying, who am I? Hopefully, host name, sorry, apologies. And like I said, live demos are scary, so let's pray this all works. It may not. Let's get an SSH session going. Okay, all right. Let me zoom that in as well. Apologies for the, what is Zoom for this one? Got it, thank you. Thank you, everyone. Again, we need an RSC for zooming. It's so much easier. Okay, so if we send this command, this should work, and we should be able to go back to here, and we should be able to see hostname. Cool, works fine. But because we're not sanitizing data, which we should be doing, by the way, we can send some cool things like this, and this makes life a lot easier for us. So let's just restart that, make that happen. Dave, how much time we got? About 10 minutes? Yeah, cool, all right. Okay, let's send that command again, but this time, let's see what we get. All right, awesome. We have a connection, so let's just, okay. So I will say this is in a Docker container. Oh, it's like Docker Compose running on the server. So we're in Docker container on that server. And some of you might think, well, what can you do with that? There's nothing really interesting. It's just in a Docker container. So let's go to my cheat sheet of commands that I wrote earlier, just to make this a lot easier for us. So let's run this command from my terminal here. And let's see what we get. All right, that is a totally valid Azure authentication token for my Azure environment. That is the bearer token here. All that gobbledygook right there. Sorry, apologies, all of this. You can copy that and use it and abuse it. I'll rotate them later, so that's fine. But that is totally valid. So that is the instance metadata service on an Azure EC2 instance that has a managed identity role. So Azure manages it all for you. They inject it into the VM. My Docker container can still access it because it can do commands back to the host. And I can see that stuff there, so it's just really cool. But what can we do with it? Well, let's have a look. So let's see if we go back to our cool list of commands. I will preface here is, and it's probably a bit hard to see, AWS is exactly the same. It's just very simple. You just call it if you're using version 1, set your CLI configuration, and you're off to the races. You're having a good time. Azure is a little trickier, and that's fine. So let's see if we want to list key vaults, because that's kind of cool. We might want to see what we can do there. So let's quickly just put some of this together real quick. Again, we're doing live here, so let's hope this all works. Yep, so that's the... So we'll do this first, actually. Sorry, apologies. So for those of you who work in Azure, you're probably like, yeah, cool, you got a token, but you have no idea what the subscription or the resource group is. But if you go and post this command, again, gobbledygook, but it'll actually tell you here. Subscription ID is here, resource group name is here. So I have everything I need to make this happen effectively. So I can copy that. And then this is more like, we've gone past APIs here, and we're more into like how we actually move through cloud providers, but it's just good to know that Azure, AWS has it, but so does Azure. So don't think that just because you're in Azure, you're safe. You're never safe. There's always problems that can occur. So if we take that command that we have here, so we copied subscriptions right through to here. So if we take that, and if we go and put that into here, providers, yep, great. And then let's grab our bearer token. And so, by the way, this virtual machine on the left here, your left, yep, that is AWS at the moment, because that's doing the reverse connection, the reverse shell. I'm now going to run this on my local machine, because I don't need to use that anymore. I've got creds. I'm good to just keep going with winning, effectively. So let's take this command and have a quick look. Is this zoomed in or not? I can't tell. It's not. So let's just give that a bit of a zoom in. Everyone okay down the back with that other side? Yep, beauty. I saw a hand up. Excellent. All right, hopefully it works. Okay, and what we see here is it has listed the key vaults. And it's hard to see, but effectively we go and have a look in here, what you'll see is this value right here, vault URI. That is the key vault that is assigned. And you'll see this more often in Azure environments where they'll set up an EC2, an Azure VM or some sort of thing like that, and they'll say, I have my secrets in a key vault. Yes, you do, but I can have your secrets too if I have that access. And people don't realize that. So I have that, and that's really cool. The problem is, though, is I have to, Azure, like good OpenID or OIDC providers, they have audience requirements in their tokens. So you would have seen this command, the original command we used, and I'll go back up to it here. We're stating that the audience has to be management.azure.com, and that lets you essentially access the management plane of Azure. But we want to access the key vault itself, and they use different audience claims, so you have to regenerate tokens, right? This is where it's a bit more complex in AWS, but it's still the same principle. And this is where, like, if you're setting up Azure environments, and again, we're way off topic here, but it's just good to go through. We're setting up Azure environments, you don't have to give it permission to the resources like I have here. If you just have it on Key Vault, you can say, just talk to Key Vault. It's a bit of security by obscurity, but if you don't know that's the sort of how to navigate it, it's there. So what we can do is we can essentially, again, take this same token that we have here, because it's, not same token, sorry, we can go back to our cool list of things to do, and we can go and generate ourselves back to our shell, we can generate a new token, and this bearer token is going to be used for Key Vault. So we can use this one now to actually go and access the Key Vault, because we've already got the subscription, the resource group, the Key Vault URI, and now we've got valid credentials for Key Vault. We're off to the races. We're making money here. We're printing money effectively at the moment with people's secrets, or my secrets for that matter. So let's have a look here. Right, so let's go and put this in, put a bearer token in here. Let's copy that out. And let's go back to this one because we don't need to use that. And let's go paste. And so this command here is just going to say list the secrets in that key vault. And what we should see right here is third-party key is a secret. And Azure's really cool in giving the whole URI, so you don't have to really work for it. It's just like nice in there in front of you. Anyone who works on Microsoft in here, I'm sorry, I'm not picking on Microsoft. It's just interesting to work with and understand. And if we go to here, and I'm about to finish, this is the last one. And if we go here, and what you'll see right here is value is super secret system. So that is one of the potential outcomes of having these instance metadata services available to instances. If your application or API is exposing some really nasty vulnerability, you can get to this point where you can own the entire system. So just wanted to add that demo, add some little bit of flavor and context to this whole story. You've got any questions, I'll be around this afternoon and tomorrow. If you're like, hey, can you go do that on GCP, which I'm going to do today or tomorrow, I will show you. But thank you all for listening. Appreciate it.